Hello everyone, under blessings of Sri Shivaratri Deshi Kendra Mahaswamiji, initiative of JSS Academy of Technical Education Noida, and today I am Bharat Kuppal, Assistant Professor JSS ATE Noida. Today we are going to study about Smith chart in depth as requested and spoken on Zoom class. Like how can we solve the problem on a chart. So let me assist you doing that with the help of virtual lab also today. So it will be considered as a lab part video. So understand and try to plot Smith chart and submit your assignment on Google Classroom. So let us start our PPT with the help of the Smith chart. Okay, so problems on Smith chart. So in the previous two lectures, we understood like how we can utilize Smith chart as a tool to solve the problem of transmission line. So today let me brief you the things what we had studied. See, I have taken it very simpler way as a transmitter and an antenna and a coaxial line between. Same way in a microwave lab we will give the power supply through Klystron power supply and transmission line. It can be coaxial cable or waveguide, any form, and there is a load. Here in this case it is an antenna. You already know that. Okay, so these load of this should match with the transmitter load. That is impedance matching should be done. So this is the idea of how the transmission line and what we are plotting. Impedance is given by the equation. It's already well known to you. You can derive. You have derived it on the previous lecture also. Z is the coordinate system. Cartesian coordinate we used, polar coordinates we use, and we came to this conclusion, this equation. You know this. Where this equation comes up, real and imaginary part are. Why it is identified, we will see in the Smith chart. Okay. So how to plot a Smith chart? I have identified it as there are 4 steps to. First is normalizing. You know that the normalized formula. We have done it. Next, find the normalized real part. Okay, first what we'll do, step 1. What is normalized? So if I take this form, this is the thing we are using. If I take this, it is saying that it is ZL. ZL is nothing but Z load. So 34 divided by Z naught output plus 34, sorry, J 34 divided by 34. What will be the answer? 1 plus 1J. Right? This is first step. What is that equation? 1 plus 1J. So this is like ZL ZL divided by Z naught. Right? This is nothing but our normalization formula. So using that formula I got 1 plus 1J. Next, what is the second step? Second step is identify normalized real. See, this is identify real is nothing but 1. See, you can see here. See, you can, this one is nothing but our R. R plus JX. X normalized other part. X is equal to X equal to 1 plus 1. Okay, plus 1. So we have identified all the 3 steps. So you can see here, first step is doing ZL by Z0. We got 1 plus J1 here. Next, identify real part 1. What is next is identify imaginary part, that is also 1. Plot the point of intersection. Now we know this. We will come back to with the help of this graph only, just for the sake, just for the understanding. We'll plot a graph neatly. Okay. Okay. Now we'll see that it is 1 plus 1 j1. Okay. So now we think that uh, 1 is here. Maybe it is not visible, but still. So this is 1 point. That is real part 1. 1. So 1, I will draw a circle, real part 1. I will trace this line. Just tracing this line. So I have traced this line. That is 1 real. Now we will see where is 1 for imaginary. Imaginary can be seen in this, since it is plus on the positive of cycle. Then 1. This is 1. Now what I will do, this point, this line I will trace on the Smith chart. This line I will completely trace. The intersection point, what we are getting here is the final step. That line is called as what it is called as? It is called as normalized impedance. That we have to calculating unknown impedance can be calculated here. This is how we can solve a problem for given load. Okay, next we'll take one more example. See, 300 minus j50 ohms, and output impedance is 100 ohms. So how we can calculate now? See, divided by 300 divided by 100 minus j50 by 100. So it will be, what it will be, 3 minus j 0.5. So here the real part is 3, imaginary part is 0.5. Okay, so these two should be plotted on the graph. So we'll go back here now, go to the graph, go to this graph. Since it is minus, I will take lower half of the circle. Now see, the equation was 3 minus j 0.5. So 3 I will identify here. 3 can be identified. 2, 3. So the real part 3 is this. I will trace this circle. Trace this circle. Next is minus 0.5. So here I can say it is 0.5 here. So what I will do, I will trace this line. I will trace this. Now what I am getting, the intersection point here will give the impedance impedance normalized normalized of this of 300 minus 50 minus 50 and output impedance is 100. For that, this is the impedance, normalized impedance. Okay, like this you can plot, find the normalized impedance on this picture. This is how you can, by using these 4 steps, you can get to the next. One more important aspect here is finding VSWR and reflection coefficient, that you can easily solve. I will show you how on the software given virtual lab. So I will take this. There are 3 I have given, one I am taking. So this is in 100 and divided by 50 minus j, 100 divided by 50. So this will be like 2 minus 2 minus j2, right? So normalized ZL divided by Z0, ZL divided by Z0, that you got this. I will go to this. Now I have to find the VSWR, voltage standing wave ratio point on the Smith chart for the following load ZL and Z0. Okay, done. So the equation is this. So we go to this circle. Let me use the circle. Okay, and the equation given, what we got was 2 minus j2. Now I have to find 2 point on the real. So 2 into 2, this is the circle. So I will trace this line. I'm just tracing this 2 line. This is now minus 2 can be found. This is 2. So I will draw. See, there is an intersection, I can see this intersection. Take the compass, take the radius of this intersection from the midpoint and draw a circle with the same radius. The point where it is going to cut the line, real axis, that point value is nothing but our VSWR. Understood how we can solve? Let me do solve one more problem like this. Okay, so let us take one more example here from the previous line. See, 50 plus j100. So let me start taking that 50 divided by 50 plus j 100 divided by 50. The answer will be 1 plus j 2. Okay, we got this. 1 is in the real axis, 2 is plus 2 is in the imaginary. So go back here, take up the, write down the equation 1 plus j2. Now where I can find it on the R1, this is, so I'll plot this circle. Okay, I will trace this circle with unit R equal to 1. Okay, that's next. Plus 2, where I can win 2 is here. I will trace this. Trace this line. Now I got an intersection here. This is my intersection point. Now from the middle, take the radius. And with the same radius draw a circle. I will draw a circle. The point where it is going to cut, that is our VSWR, and the ring which is formed here is called as VSWR rings. Okay, try it out. Become simple. 1 or 2 times if you try it out, you will easy. And have written the steps also, what we have to do. That we have done it for one more example. You can try it out for 50 minutes. 0 plus 50 plus j0. Okay. So next point is how to conduct this experiment on online virtual lab. Use your virtual lab. Go to this link which I have shared it through email. Once you click on this link, it will ask for login. Just create one login. There is no much issue, and moreover you have created in your earlier labs, so there is no much issue. Click open. Okay, so once you it's taking some time to load. Okay, so let us go to this and we will select this our experiment. See, Smith chart. Okay, select Smith chart, introduction to Smith chart. It will ask for user which you have created earlier. Okay, once you log in, select the basic introduction to Smith chart. You can run any using runtime engine which is provided online. You can click on this, you can run the software. Let me tell you the procedure. Before that, let me tell you what is the aim. Basic drawing of a Smith chart we have come across through the video. How the VSWR rings are formed we have come across. How to identify impedance, unknown impedance, that is also done. See, unknown impedance, and whether it is open circuit or closed circuit, you can clearly understand whether it is an inductive, resistive, capacitance circuit. That can also be what is constant resistance circle, what is constant reactance circle. All these can be identified. You are already ready with identifying all this. That is what the experiment is going through. So, and next we'll go to the procedure. Once this runtime is getting go ready, by that time you can see what are the procedure and what we have to do. See, you can see here that you can give the characteristic impedance, you can give the load value, whatever we did right now, and there will be a Smith chart available also here. So in the software you will just enter the load point values, ZL, Z0 and everything, and you will get a Smith chart. From here, when you just click on the runtime engine and you will go to the lab view, it's a cakewalk. You can easily know how to enter the values here, and how to get the Smith chart, so that you can cross verify your plotted graph using this virtual lab software. Okay, I feel from here it is very very comfortable, and they have explained it step by one, step 1 2 3 like that. We had 4 steps, they have only 3 steps to get answer. So you can enter the values here which I am showing here. See what is the node, what is the characteristic impedance, what is Z0, ZL, all these things. See, the Smith chart is also getting loaded here. Okay, I feel the later part you can easily complete it. Let me give you the quiz or the assignment through Google Classroom. Thank you.